Hello world, Noah here. In this video we're going to be talking about division and modulus and some of the tips and tricks that you can do with these operations. Now, this video might seem pretty basic for some people, especially if you have a lot of experience in programming. I'd encourage you to just watch or maybe even just skip through it because there might be something new that you didn't think of or that you didn't learn. But if you're someone who's newer at programming, these tricks will help you out quite a bit. And I'm going to challenge you at various parts during this video to pause the video and think about the answer before I actually show it to you. So as the title suggests, we're going to be talking about the division and modulus operators. And we're going to be talking about them in Java and Python because they do work slightly differently, and it's important to notice the differences. So on the left, I have Java 8 running in Eclipse. In the top right here, I have Python 2.7.10. And on the bottom right, I have Python 3.6.1, because there is actually a difference between Python 2 and Python 3 when it comes to division and modulus. So first, let's get the easy one out of the way. What is division? Well, it's the exact same as it is in math. You're taking one number and you're dividing it by another number. It's pretty simple, but there are some important caveats that you'll notice when you're programming. So I'm going to go ahead and write a print statement here. And so for example, if I print out 4 divided by 2, from math class you'd expect that to be 2. And I hit run, and it does indeed print out 2. So that makes perfect sense. Now, it does get a little bit weird sometimes. For example, let's say that I print 3 divided by 2. You'd expect it to be 1.5, right? But in Java, it actually says 1. Let's compare how this works in Python 2. So I'm going to type in 3 divided by 2, and it says 1. But if I do that in Python 3, it's going to say 1.5. So it seems like Python 3 is the only one that works, and the other two maybe don't understand how math works, but there is an important difference, an important distinction to note here. As you know from your very first or very second programming lesson, the data type integer stores whole numbers, and we know a whole number is just a number without a decimal place in it. So if you look at these values, 3 and 2, you'll notice that they're both integers, right? They're both just whole numbers with no decimal place. So in the case of Java and Python 2, it notices that you have 2 integers that you're trying to divide, and it figures that you probably want the answer back as an integer. And so it gets 1.5, and it truncates, meaning it chops off the 0.5, and it gives you 1. Notice that it doesn't round. It doesn't take 1.5 and round it up to 2 like you might do in math class. It just truncates so that you can have the same behavior no matter what the number is. So for example, 1.99999 would still truncate to be 1. And this is actually useful behavior, even though it might be counterintuitive based on math class. But you'll notice that Python 3 still works. It gives 1.5, because even though these are integers, the division like that automatically treats it as a floating point number. So Python 3 works. Let's look at how to fix this in Java and Python 2. So the easiest way to fix this is to just convert one of these numbers to be a floating point number, either a float or a double. So for example, if I made this 3.0 divided by 2, then it gives 1.5. I could make this 3.0 divided by 2.0, and once again it would give me 1.5. Or I could make it 3 over 2.0. As long as at least one of the numbers is a floating point number, a number with a decimal place, this will work correctly. The reason why is because as long as at least one of these is a floating point number, it will convert the other number into a floating point number automatically, and then it will do the division. And division between floating point numbers will of course give you back a floating point number, or a number with a decimal place. And the same thing is true in Python. So 3.0 divided by 2, 3 divided by 2.0, 3.0 divided by 2.0. In all of these cases, you get 1.5, which is what you expect. But let's say that you have 2 variables. Like let's say we have, int x equals 3 and int y equals 2. And then you have a bunch of code in the middle. And then you finally see that you have x divided by y, like that. This will, of course, give the wrong answer. It'll give 1. I should say it would give the wrong answer as far as conventional math is concerned. It gives the answer with the decimal place truncated. But imagine that we can't change the types of x and y. We can't make x be a float or a double. We just have to work with x and y as we have. So what we would need to do is we would need to typecast one or both of these values. And the way to do that in Java would be to just write, for example, float in parentheses, or you could write double in parentheses, but we'll go with float, just like that. And if I hit run, it'll work. Because what happens is it takes x and casts it or converts it to a floating point number, and then it divides it by y. Note that this behavior will not work. If I do x divided by y in parentheses and then convert it to a float, I'll get 1.0 because it's first doing x divided by y as integer division, and then it's converting the results of that into a floating point number. So you need to make sure that you convert the individual operands like x and y and not the results of the expression, or else it's not going to work how you expect. So writing it like this is essentially the equivalent of putting parentheses like that. So it'll first convert x to a floating point number and then divide by y, which will make it work. Now in Python, it's a little bit different. We would basically just use float. Well, actually, let's just say x equals 3, y equals 2, like we had before. And of course, x divided by y will not give us what we want, but we can do float x divided by y. We're converting x to a floating point number and then dividing it by y. And once again, float quantity x divided by y doesn't work. So it's pretty much the same exact thing as in Java, except here we write float in parentheses and then the value. Here we write float and then we write the value in parentheses. So just slightly different syntax. If we have a floating point number, so for example, float z equals 1.5, or I guess we need to write 1.5f if it's a floating point number, or we could write just double z equals 1.5, just keep it nice and simple. And we wanted to convert this back to an integer, we would just simply cast it to an integer like that. And you'll see it would print out 1 right there. Takes the 1.5, truncates the 0.5, and just prints 1. And in here, if we had z equals 1.5, we could just convert z into an integer, and it will be 1 again. Let's take a look really quickly at how to emulate this behavior in Python 3, because as we can see, doing 3 divided by 2 gives us 1.5. But what if we want to do the normal old division? The way to do that is to write 3 divided by 2, but with 2 slash signs, 2 division signs. This will basically force division, force integer division. So 3 divided 2 will give you 1. That will do division with truncation. So take note of which version of Python you're using. And note that over here, if I do x divided y, then it will do the same thing. So you can write 2 division signs and have it work in Python 2 and 3. But basically it'll do the same thing in Python 2 as we did right here. But in Python 3, one of them will do regular division and 2 of them will do integer division. So now that we understand division, we can talk quickly about modulus, and then we can look at a couple of tricks that we can do with division and modulus. So modulus goes with division, and modulus is for calculating the remainder of a division expression. So for example, let's just go back to what we had before. I'm going to do x divided by y here, and as we know, x and y are integers, so we're going to get an answer that's an integer, and it's going to be 1. Now if I want to calculate the remainder, imagine that we're doing long division, 3 divided by 2. And I could say 2 goes into 3 one time, 3 minus 2 is 1, so the answer would be 1 with a remainder of 1. If I want to calculate the remainder, I do x mod y, and the modulus symbol is the percent sign like that. So if I run this, you'll see I get 1 and 1. That means x divided by y is 1, and the remainder of that is 1. There are times where you'll want to do integer division, and there are times where you're going to want the remainder, and so that's how that works. It's the exact same thing here in Python. So for example, let's just remind ourselves that x is 3 and y is 2. X divided by y gives me 1. and x mod y also gives me 1. So it's the exact same behavior. And then over here, I can define x equals 3 and y equals 2. I want to do the integer division. So x divide y gives me 1, and x mod y also gives me 1. So I get that same behavior in all three of these. There is a quick little trick in Python that you can do if you want to know both the division and the modulus result, because there are times where you'll want both. You can do something like this: div comma mod equals div mod x comma y. And then we can print out div and mod. So what happens is you write div mod like this. It's a function defined by Python, and you give the first operand x and the second operand y, and it will give you two results, the division and the modulus. And I assign the first result to a variable called div, and the second result to a variable called mod. And if I print this out, you'll see div is 1 and mod is 1. So if you want to do this on one line, instead of doing x divided by y, x mod y, you can do it just like that, and it'll let you do it on one line. Let's see the same behavior over here. Div mod x comma y, div mod. Exact same behavior in Python 3, so there's no difference there. That's just a little trick that you can do to do division and modulus in one line. But if you look at the implementation of the div mod function, it just does regular old integer division and modulus. So there's nothing really special about it there. Now that you understand division and modulus, hopefully, we can talk about some tricks that we can do. Now, I forget how to clear the console, so maybe we can't clear it, but that's okay. So the first one's going to be very simple, and this is probably one of the first things that you learned, probably when you learned how to do if statements, but checking to see if a number is even. So based on what you know now about division and modulus, take a second to think, how could you calculate if a number is even or odd? Okay, this one is actually quite simple. All you would need to do is check the remainder of dividing your number by 2, right? And if there is a remainder, you know it's an odd number. If there isn't a remainder, you know it's even. Because any number is even if it's evenly divisible by 2. Another way of saying that is any number is even if you can divide it by 2 and the remainder is 0. So for example, I could print out x mod 2 is equal to 0. And that will print out false because x is 3. That's an odd number. And I could print out right below it y mod 2 is equal to 0. That will print 2 because y is 2. 2 mod 2 is 0. And of course I could change this, maybe x is 5 and y is 6, for example. It'll still work. 5 mod 2 is not 0 because it's an odd number. 6 mod 2 is 0 because it's an even number. So that's an easy way to tell. And of course you can do the same thing over here. So let's say x equals 5, y equals 6. X mod 2 is equal to 0. That's false. Y mod 2 is equal to 0. That is true. And the same exact thing will work inside of Python 3. So that one is really quite simple. Let's take a look at the next one. There's a good trick that you can do with division and modulus by 1. So take a second to think. Dividing a number by 1 and doing the modulus of a number by 1, what could that possibly tell you? Okay, so for this one, we're going to want to work with a floating point number. So let's go with double z equals 1.5. I'm going to do this in Java first. So we have z equals 1.5, and what we can do is we could divide this number by 1. Actually, this won't work for us in Java. But essentially, we could, let's just take a look at the modulus. So we could do z mod 1. What will the result of this be? Think about it for 1 second. And I'll go ahead and run it now. And the answer is 0.5. Now what's significant about that? Let's say I change this number to be 2.75, like that. I run it again and that's what you get. So as you can see, this is basically telling us the decimal part of the number. So doing modulus by 1 gives you the decimal part of a number. And we know if we want to get the integer part in Java, we could just cast z to an integer. So if I run this again, it says 2, and then it says 0.75. So this will allow you to separate a number. Basically, it will allow you to separate the number into the whole part and the fractional part. And then you could use this something like, imagine you have a double and you want to check to see if it's a whole number or not. So 2.75, we can isolate the decimal part, which is 0.75, so we know it's not a whole number. But if I make this 2.0, we isolate the decimal part is 0, so therefore we know it's a whole number. So this is just a little trick that you can do if you want to pull the decimal part out of a number really quickly, and that can definitely be helpful. Now in in Python 2, let's take a look. We're going to make z be 2.75. Once again, we could convert z to an integer, or we could force integer division like this. So z divided 1. You'll notice that it gives the answer as a floating point number, but it still did what we wanted it to do, and of course z mod 1. So we can see you can either convert z to an integer like we did in Java, or you can do the integer division by 1, and then after that you can do the modulus by 1, so we can separate basically the whole part and the fractional part. Over in Python 3, z is 2.75. We can do z divided by 1 and z mod 1, and that's great. And of course, you can also do this with div mod. So for example, div comma, so let's just call it div mod, and we're doing 2.75 divided by 1. So div is 2 and mod is 0.75. So it does the exact same thing as we would expect. But that will allow us, using 1 as our number, will allow us to separate the fractional part from the whole part. So if you want to know, for example, if a number is a whole number, if you just want to know the fractional part of the number, so on and so forth, instead of relying on, string parsing and some ugly things like that, you can just use division and modulus by 1. Okay, so now we're going to talk about division and modulus by 10. So we just talked about 1, and when we talk about 10, it's going to be kind of similar, but a little bit different. So I'm going to go ahead and this time make z let's make it an integer number, and it's going to be equal to 123. And I want to do z mod 10, and I'll put the division above that. I want to put z divided by 10. Remember, this will be integer division because z and 10 are both integers, so think about what this will do for just a second. And I'll go ahead and run it. We get 12 and we get 3. So the important thing is, in this second one, z mod 10 will basically give us the last digit in this number. In this case, it's a 3. Because what happens is we're saying, what's the remainder of doing z divided by 10? So 123 divided by 10 is 12.3. Then we want to calculate the remainder of that, and so we have 0.3, which is 3. So that's basically our remainder. It would be 12.3, and the 3 is the remainder. So that's where we get 3 from. So basically, doing z mod 10 will chop the last digit off of that number, and then doing z divided by 10 will give you the other piece. So you can combine division and modulus like that to separate a number into its chunks. So first we did z mod 10, and that's going to just get us a 3 by itself, and then we want to do z divided by equals 10. So we basically want to chop the 3 off, and then we want to divide z by 10 to get rid of that, because z divided by 10 will be 12.3. It'll ignore the 0.3, so now we're down to 12. Once again, I can call z mod 10 on that number, and then that should print out the middle digit, which is 2, and I could do z divide equals 10 again. Finally, I could just print out z because it's one digit. I could print z mod 10, it would do the same thing, but you can see it goes 3, 2, 1. It takes that third digit, then it takes out the second digit, and then it takes out the first digit. And if I made this some random number, 451, it'll take the 1, which is this digit over here, then the 5, then the 4. And if you combine this with a for loop, then, or maybe a while loop, then you could basically just make this chop a number up into a bunch of digits. You could just keep running basically until z becomes less than 10, because when z is less than 10, then you're down to just one digit left and you've chopped off all of the other digits. But that's very simple. And it does, of course, work the exact same way in Python. So z equals 451, z mod 10 gives us 1, which is that digit on the end. We can divide z by 10, and it's now 45. Once again, z mod 10 gives us a 5. We can divide z by 10, and then z is now just 4. So we can chop off the digits, and of course it works the same way in Python 3. So the last example we're going to look at is using modulus for arbitrary lengths for like cycling through values. So imagine that I have an array of colors, and the array of colors is red, green, and blue, like that. So we have red, green, blue, and basically I just want to cycle through these colors infinitely, and I want to print out the values of red, green, blue, red, green, blue, red, green, blue, so on and so forth. You could imagine I'm like assigning teams to a bunch of different players, or whatever you want to imagine, but I'm basically just cycling through those three values infinitely. I'll create a counter variable, which I'll call I, and that will basically tell me where in the list I am. And then I'm going to write an infinite loop, but you can imagine this is running in another thread, or it's running a set number of times, whatever you want to do. But then basically I want to print out the color that I'm currently looking at, and then I want to increment I, like that. So if I run this, my target is for it to print red, green, blue, red, green, blue, red, green, blue over and over again. And if I hit run, you'll see it prints red, green, blue, and then I get an array index out of bounds exception. This shouldn't be a surprise to anyone who has worked with arrays before, but essentially what happens is I becomes too big. I is 3, and then there's no value at index 3, so it doesn't work. We basically need I to wrap back around to be 0. Now I could add a statement, and I could say, for example, if I is greater than colors.length, then I is equal to 0. I could do something like that. Why didn't that work? If I is greater than or equal to, my bad. And okay, so you get the idea. But you can see that it goes red, green, blue over and over and over and over and over again. So this works, but it's not the best for 2 reasons. The first one is we add this extra if statement here, which is extra code that we don't need if we do it a different way. But the other reason is because this value of I tells us the index where we are in the array. But if we don't reset I to be 0 every time we reach the end, then I could also tell us the number of colors that we've generated so far. So for example, the first time I would be 0 and it would give red, then I would be 1 and it would give green, I would be 2 and it would be blue. Now if we don't reset I and I becomes equal to 3, then it should give us red again. I is 4 would give us green, I is 5 would give us blue, 6 would go back to red. So we could still use I to tell where in the array we are, but we could also use it to tell how many colors we've already generated so far. So for example, we could use this with a for loop, and let's say we want to generate 30 colors. For example, we want to assign 30 people to one of these 3 teams in our example. And so if we don't reset I, then we could use I to tell where exactly we are as far as generating colors. And so we can just combine, we can just use a little bit of modulus that we learned before, and we can get rid of this if statement, and we can keep this behavior that might be useful. And so all we need to do here is we need to take I, and we need to do modulus by colors.length. And as you can see, it works now. It works just the same as it did before. Let me see if I can run it and then stop it quicker. It's kind of hard to stop it, but it runs red, green, blue, red, green, blue, red, green, blue. The only reason why it starts with blue is because it printed a bunch of stuff and then the console erased it because it's printing too quickly. But it does actually print red, green, blue over and over and over again. And basically the reason why this works is because as I grows bigger, we mod by colors.length to ensure that it's in the correct range. So for example, the first time I is 0, 0 mod 3, which is the length of colors, is still 0, and so it'll be red. When I is 1, 1 mod 3 is 1, so it'll be green. When I is 2, 2 mod 3 is still 2, so it'll be blue. But when I gets to be 3, 3 mod 3 is 0. So here in the array, we go back to index 0, but I is still equal to 3. So we still know that the value of I is 3, which tells us that this is the fourth color that we're generating. The next time when I is 4, 4 mod 3 is 1, so we know that we're at green, but we can still use I to tell where we are in the array. Now, if I can also get rid of the I++ and just move that right there. Basically, this will give the value of I, and then it will apply the ++ operation all in one line. So you can see that this is really, really nice, and it's a one-liner basically once you have your list of colors and your variable. But all we're doing is we're taking our counter variable, we're modding by the length of the array to ensure that we remain within the range of indices for that array, and then after we apply the ++ to move to the next position. And of course, if I printed out the value of I, we could watch it grow bigger and bigger and bigger, and we don't have to worry about it constantly resetting. And so for example, it says blue and then it says 168882. That means we've generated 168882 colors so far in our list. So we can use I basically to tell us how many colors we've generated, and if we mod by the length of the array, we could tell which color we want to generate exactly. And so that is all for this video. That's just a look at some tricks with division and modulus and a little explanation of division and modulus themselves. Perhaps you already knew everything in this video. Perhaps you're somewhat newer to programming and maybe you learned something. I hope you did. All of this stuff, even this last example, works the same in Python 2 and 3. The only real difference between Python 2 and 3 is the integer division behavior that we looked at the very beginning. So as always, subscribe if you want to see more, comment with what you want to learn. If you enjoyed this video, hit the like button, and I will see you guys soon with some more programming. Bye for now.